الأحداث والمشاهد والكوارث اليومية المؤلمة اللي يعاني منها الإنسان تثيرني لدرجة كبيرة، وبعرف السبب شنو. طبعا التعبير عن هذه المواقف بالحكي أتركها للكتاب والشعراء، إن كل واحد له أدواته التعبيرية. أنا نحات، فأترجم أحاسيسي من خلال إيدي.
It seems strange, but these horrible visions of struggle and chaos, war and poverty show something wonderful. Even the painful emotions expressed by the statue symbolize hope. This artist cared enough to record what he felt about these things. And that is what is wonderful. Of all the species on Earth, only one is conscious of its own nature. Only one records its feelings through language and art. Only one can look back through art at the pain and violence of the past and plan for a better future. Only mankind leaves its mark for future generations. Why is man, alone among all the animals on Earth, able to do this? All animals, including man, start from a single fertilized egg cell. All the information required to make a new animal or person is stored in this cell as instructions, a bit like the instructions in a recipe book that tells us how to make a special dish. We all develop by following the instructions in this cell, which are passed to us from our parents. These instructions tell the cell whether to develop arms and legs to become a person, or fins and a tail to become a fish. If the instructions are for a person, they say whether to make blue or brown eyes, to grow to a particular height, have dark hair, blonde hair, thick hair, thin hair, and so on. The instructions are in a chemical called DNA, which is found in almost all our cells. If the instructions in the DNA are similar, a similar animal gets built. Twins can have the same instructions and turn out to look very similar. Brothers and sisters have similar DNA instructions because they were given them by the same parents, and thus look similar. People look more similar to apes than to cows or fish because our DNA instructions are more similar to ape DNA than to that of other animals. Scientists have measured the similarity between our DNA instructions and those of many other animals. We share, amazingly, about 20% of our DNA instructions with plants, about 69% with fish, 82% with chickens, 84% with horses, and 87% with pigs and dogs. But most strikingly, we share about 99% of our DNA with chimpanzees, and only a little less than that with monkeys. Yet even our closest relatives, the chimpanzees, with whom we share about 99% of our genetic heritage, lack true language and culture. They share most of our emotions and instincts, sexual urges, jealousy, hunger, greed, generosity, curiosity, love and hate, and even a sense of humor. But they do not examine their conduct or express remorse for it, and they create no statues recording feelings and events. They do not plan for the future. They cannot record their thoughts in writing or even communicate through a complex language to make the way easier for their descendants, or to build significantly on what their ancestors have learned. Humans, who have had the capacity for language for at least 100,000 years, can pass on their ideas and their knowledge and leave their marks behind, although they did not do so in writing until about 5,000 years ago. Man has existed for 5 million years, which is a tiny fraction of the Earth's 4,600 million years. Everything that man has discovered or invented, which has given us the quality of life we now enjoy, has only been achieved in the last 14,000 years, since he discovered fire. If we compressed the Earth's 4,600 million years into a person's lifetime, Earth would be 46 years old. Man arrived only 7 days ago. Fire was discovered 24 minutes ago. The Industrial Revolution began just a minute ago. There is no doubt that we have accomplished a great deal in a very short time, and there is little doubt that we will progress even further and faster in the future. And there is no doubt also that our modern-day quality of life is the product of the human brain. Yet, unfortunately, this wonderful human brain has had terribly destructive effects as well. The 20th century man enjoys the fruits of technology our ancestors could never have imagined. Yet we haven't learned to control our selfishness and violence. Throughout history, we've turned our inventive minds to refining tools of war and destruction. As long ago as 1800 BC, when the invention of the light archer-carrying chariot enabled Central Asian peoples to sweep across northern India, Egypt, Asia Minor, and Europe, or as recently as 1945, when the atomic bomb brought a sudden end to World War II. Technology has been critical to military success. But as we moved from muscle power to gunpowder, and then to the use of increasingly intricate machines, we have steadily increased the efficiency of killing. The Chinese invented gunpowder about 320 years before they made paper, while Westerners made the time bomb several years before bothering with flush toilets. Our ancestors also passed down such inventions as guns and cannons from the 13th century, the metal cannon from early in the 14th, and the portable shotgun and pistol from the early to mid-16th century. All of them developed before we invented the wrench and the screwdriver in 1550. And even then, the screwdriver was invented by gun makers. Only a few natural disasters, the Japanese earthquake in 1923, the eruptions of Vesuvius in 79 AD, or Krakatoa in 1883, match the carnage of the numerous individual battles down through history. Of the 30,000 men who fought at Marathon in 490 BC, more than 1/5 died. Napoleon took 74,000 men to Waterloo, where fully 1/3 became casualties. In this century, the First and Second World Wars killed about 100 million people and cost billions of dollars. Even afterwards, the major superpowers spent $2 trillion US, which is 2 million, on defense. Money that could have been used to feed starving millions and house tens of millions of people. Build hundreds of thousands of schools, colleges, and hospitals throughout the world. Plant trillions of trees to solve the world's air pollution problem. And discover ways to cure and prevent cancer, schizophrenia, AIDS, and many other fatal diseases. But war is not a disease that afflicts only powerful countries, nor is it a mere relic of history. Religious and racial conflicts, territorial ambitions, greed for oil, land and water, even football games, have sparked wars. The decades since World War II have brought human civilization to its most developed level. Yet our skillful manipulation of technology and our inability to control our own violence has made it possible for us to watch war live on television.
And they are not aware or cannot see what they're shooting at.
I would guess, since they haven't heard any planes at all, that they're probably shooting at what conceivably could be a false alarm.
Whoa! Holy cow!
During these few decades, the world has seen wars, coups and violence in more than half the countries of the world. 20 million lives, including the presidents and prime ministers of more than 40 countries, have been taken. At least 3 times that number have been injured, and tens of millions of people have become refugees. War and violence severely retard development throughout much of the world. All of these advances, for good or ill, are the products of the human brain. Everything we do, from scratching our noses to composing a symphony or designing a nuclear weapon, requires a complex series of processes in our brain. How does the human brain make these things possible?
Achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
I'm going to step off the limb now. That's one small step for man.
All the wonders of the brain are performed through tiny nerve cells, or neurons, which communicate with each other chemically. Each human brain contains a lot of neurons, about 100 billion of them. That's about 200 times the number of human beings on planet Earth. The connections between neurons are called synapses, and some neurons make as many as 10,000 synapses with their neighbors. All in all, there are about a zillion, which is 1,000 trillion, synapses in the brain. It would take 10,000 galaxies to contain that many stars. The human brain is the most complicated object in the known universe. To get some idea of its complexity, imagine a huge telephone switchboard able to connect every single person on 200 planet Earths. And then imagine fitting the entire switchboard and all those telephones into your head. Compared to our brains, computers are simple. Counting the calculations that can be done by all our neurons shows that our brains are 1 million times more powerful than the best supercomputer. So, if the best supercomputer is worth $20 million, your brain, if we could build another one, would be worth $20 trillion. The most recent part of the brain is the cerebral cortex, which really makes us what we are, whilst the oldest parts of the brain include the brain stem and parts of the limbic system. Some scientists call the brainstem the reptile brain because it resembles the entire brain of a reptile. In humans, it is primarily concerned with keeping the heart pumping, the lungs breathing, waking and sleeping, body temperature, and other simple tasks and reflexes. It contains our medulla oblongata, pons, and midbrain. It also contains the reticular formation, a long tangle of cells and fibers running the length of the brain stem. Much of the brainstem, though, is white matter, huge tracts of fibers through which information passes to and from the brain. Attached to the brainstem is the cerebellum, which handles memory for simple learned responses. In concert with other areas of the brain, the cerebellum helps control movement and balance.
Again, they're in possession just inside their own half. Maradona turns like a little eel and comes away from trouble. Little squat man comes inside Butcher, leaves him for dead. Outside Fennick leaves him for dead and puts the ball away. And that is why Maradona's the greatest player in the world. He buried the English defence. He picked up that ball 40 yards out. First he left one man for dead. First he went past Saxon. It's a goal of great quality by a player of the greatest quality. It's England 0, Argentina 2. The first goal should never have been allowed. But Maradona has put the seal on his greatness. He's left them comfort on this World Cup. He scored a goal that England just couldn't cope with. They couldn't face up to. It's England 0.
The hypothalamus, the name means below the thalamus, is just above the brainstem. It is central to life-sustaining functions. It is the headquarters of the autonomic system of nerves and of the body's hormone system. As it sends and receives transmissions from above and below, it is an essential sorting office of nerve signal traffic in the brain. The hypothalamus is also involved in feeding, sex, and sleep. It controls the brain's master gland, the pituitary, which pours hormones into the bloodstream. The pituitary gland is just below the brain, a short distance behind the eyes. It sends out hormones that regulate our blood pressure, thirst, growth, sexual functions, and many other essential aspects of our bodies. So far, all these parts of the brain are responsible for internal bodily functions. Now we come to parts of the brain that are responsible for processing external sensory events. The thalamus is located right in the middle of the brain. It is the gateway to the higher region of the brain, the cortex. Almost all sensory information, mechanical information in hearing, balance and touch, chemical in taste and smell, or light energy in vision, which is processed in the brain, is relayed through the thalamus. The thalamus contains many specific nuclei. Each of these receives input from a particular sense organ, or from the cerebellum, and sends the information to the appropriate area of the cortex. The limbic system contains the hippocampus and amygdala. The hippocampus plays a major role in conscious personal memories. It helps put things into context. It receives information from many areas of the cerebral cortex, processes and holds signals temporarily, and, if they're important enough, sends them back into the cortex for more permanent storage. It may give the frontal lobe information about what has happened recently, so that the frontal cortex can decide what to do about it. In fact, it's believed that the hippocampus is the printing press for memories, since without it, we can't make any new memories. The amygdala, the hippocampus, and the surrounding structures also translate bodily needs and sensory perceptions into emotional reactions such as fear and aggression. Above all these other structures lies the cerebral cortex. For our size, the cortex is larger and more intricate than that of any other animal. It is the part of the brain that's most responsible for our advantages over other animals. We think and function as well as we do because during evolution, new regions have been added to the cerebral cortex. Without it, we would not be capable of thought or consciousness.
Poor little children will one day live in a nation where they will not be judged by the color of their skin, but by the content of their character. I have a dream today.
The cortex is divided into two halves, or hemispheres, each of which relates to its opposite half of the body. The two hemispheres are connected by the corpus callosum, and each is covered by a 2 millimeter thick, intricately folded layer of cells called the cortex. Thin as it is, if flattened out, the cortex would be a meter or so in surface area. The cortex of each hemisphere is divided into areas that have different functions. The visual cortex, or lobe at the back, is involved in vision. The temporal lobe at the side mainly handles hearing, the parietal lobe for touching, and the underside of the brain for tasting and smelling. The frontal lobe is the largest and is most responsible for what makes us human. It is responsible for planning, decision-making, and purposeful behavior. The ability to plan for the future helps distinguish us from all other species. The frontal lobe's function is not speech, not vision, not hearing, not touch, nor does it have full responsibility for memory. It controls how we use the information other parts of the brain gather. It's an executive brain area, responsible for integrating information from many different brain systems. It develops purposeful plans of behavior, anticipating the future, surveying situations, juggling different responsibilities, and choosing the one offering the best future prospects. Then, via the motor cortex of the frontal lobe, carries out the appropriate action. How good we are at these things largely determines how intelligent we are. So, everything we see, hear, touch, taste, or smell is relayed by the thalamus to the appropriate part of the cortex for processing. The cortex identifies important features of the sensory input. If the signals relate to food, for example, the cortex identifies what food it is. If they are visual signals, the cortex identifies what object is present and where it is. If a voice is being heard, the cortex identifies whose voice it is and what is being said. Once these sensory signals are processed, the results are sent to the frontal lobe, the executive part of the brain, to decide what to do about it, and to the hippocampus for temporary storage.
Yeah, excuse me, please. الو يا هلا اي نعم اهلا 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 الله بالخير واحمد شلونك؟
الو نعم.
هلا انا وياك ترى رديت. ايش فيك؟
لا ماكو شيء. شلون كانت؟
شو اللي شلون كانت؟
تقول لي رديت؟ شلون كان اللي رديت منه؟
مو فاهم عليك.
شنو اللي مو فاهم علي؟
ما علي ما علي، اسمع خلصت السيناريو؟
الحقيقة لا، لين الحين. صارت عرقلة شوي.
ليش؟
تعرقلت.
وين اي صوب؟
مشهد التليفون هو اللي موهقني.
شلون ليش؟
ما ادري، مو راضي يضبط وياي.
تبي اساعدك؟
يا ريت، بس ما افتكر تقدر.
زين ماشي. شو السالفة؟
ما ادري، شيء غريب.
شو اللي غريب؟
زين
شو السالفة يبا؟
اوه لا راحوا.
من هم اللي راحوا؟ خاف يتراوالك.
ها؟ لا لا عادي عادي ماكو شيء.
انزين على العموم متى تفكر انك تخلص المشهد؟ ترى ما عندنا وقت.
المشهد لا تحاتي، خلص كاو خلصته.
Unlike the cortex of most other animals, the two hemispheres of the human brain have different functions. As well as being responsible for receiving perceptual signals from different sides, the two hemispheres have responsibilities for different aspects of our mental processes. In most people, the left hemisphere is dominant for speech and most aspects of language. It is specialized for controlling speech and writing, and interpreting the speech and writing that we hear or see.
The result of the mission that brought me to London, I know that I shall carry with me the pleasantest memories of my stay in the midst of the poor people of East London.
The right, by contrast, predominates in analyzing spatial arrangements, recognizing objects, appreciating music, and determining emotional reactions. The two hemispheres are normally connected and work closely together. But when their connection is damaged or has been cut as a treatment for epilepsy, the two sides cannot communicate. This has strange effects.
We want you to concentrate on the red light.
For example, if the right hemisphere of such a split brain patient, but not his left, is shown the word house, the patient will deny seeing the word. The right hemisphere cannot tell the left, language hemisphere, to interpret and say the word. But if the same patient is asked to draw with his left hand, which is controlled by the right hemisphere, he can draw a house in response to the word. So, the right hemisphere may be conscious of what it sees and does, but lacks the power of speech to express it.
مثلا هذه شنو هي هذه؟
مش قادر بس أنا عارف.
ما تعرف ما تقدر تقول اسمها بس تعرف استعمالها.
أنا عارف هنا عارف إذا بص.
شو يسمونها؟
مش قادر.
أساعدك أقول لك نظارات.
نظارات هنا.
The discovery that our language functions are generally in the left hemisphere was made in the 19th century. Two doctors, Paul Broca and Carl Wernicke, found that damage to areas of the left hemisphere resulted in an inability to use language properly, a condition called aphasia. Speech impairment follows damage to Broca's area, which is near the front of the left side of the brain, just in front of the portion of the motor cortex that controls movement of the mouth. Aphasic patients with damage to Broca's area usually know what they want to say, but their speech is often a kind of verbal telegram.
الو
بس مش قادر اسمه الو.
يعني
الو.
كيف استعماله؟ تقدر تقول
الو. مش قادر ابي. اسمه
تلفون.
تلفون. فرو.
نعم.
لا.
في صعوبة بالنطق.
خلاص مش قادر. بعدين ابي.
بس عارف ان هذا يستعمل.
ما انا عارف يعني بص.
انا بشرح لك شنو هو فيك. انت ما قالوا لك شنو بالضبط عندك؟
لا مش عارف.
هو اللي عندك حصل جلطة صغيرة في جزء من المخ. اللي هو الجزء الايسر. الجزء هذا مسؤول عن النطق. فهذا عطلان. حصل شريان صغير من سد، فالمنطقة هذه تعطلت.
وبعدين ابي.
فهو يعني تحتاج تمارين على طول، تمرن علشان يمكن الجزء المقابل من المخ اللي هو الجزء الأيمن أحياناً بيشتغل بدل المنطقة هذه. بس هذه المنطقة هي اللي متخصصة بالنطق.
Because of the specialization of the left hemisphere for language, the right hemisphere has been able to specialize for spatial processing. Damage to the right hemisphere can lead a patient to deny the existence of the entire left half of the world in a condition called neglect. But because of the special responsibility of the human right hemisphere for spatial processing, all people with this problem neglect the left half of the world.
قال لهم خلاص احنا يعني مثل ما تقول اذا بنكمل راح نستشهد، فاللي يحب انه يطلع ويقدر انه يطلع واحنا نعطيه تغطيه خليه يتوكل على الله، واللي يبي يقعد ويبي الشهاده هذه الشهاده موجوده. فكلنا قلنا لا ابو سامي احنا قاعدين. فقال زين بدام انكم قاعدين خلاص يطلع اثنين، طلع الشهيد عامر الله يرحمه والنقيب يوسف، طلعوا فوق السطح وحطوا العلم الكويتي. فلما حطينا العلم الكويتي فوق السطح جن جنونهم وقاموا يرمون ويطلقون نار عشوائي اي مكان، وبالاخص السطح وعلى العلم على اساس انه ينزلون العلم الكويتي. فاقدر اقول ان هذا كان اول علم كويتي ينرفع قبل التحرير بيومين.
Another specialization of the human brain is its memory. Elephants never forget, and neither do people, if something is important enough to be remembered.
ولما جتني طبعا بين الار بي جي وضربوا ضربه هني ونجيت منها، جت تحت البرواز من برا بهالمسافه هذه.
Human memory, like vision, is more highly compartmentalized than earlier generations realized. Memory for the last few seconds is kept mainly by a circuit that involves the hippocampus, while material to be remembered more permanently is passed back to the cortex. Memory for performing skills seems to involve the cerebellum, and memory for what happens to you seems to be stored in a different place to memory for what words mean. So, memory is actually a diverse set of talents which may each depend on different learning mechanisms and involve different areas of the brain. Damage to the different parts of the human memory system can result in strange and frightening disorders. In the 1950s, surgeons discovered that when the hippocampus was destroyed as a last resort treatment for severe epilepsy, the patient could no longer form new memories. Such patients could recall events from the past up until shortly before the surgery, and they could maintain for a few minutes a memory of the immediate past, but they could no longer form permanent memories. They couldn't learn. Other patients with accidental hippocampal damage can recall quite accurately up to the time of their accident and retain full faculties of language, intelligence, and problem solving, but cannot recall anything that has happened since that time, even events from only 10 minutes earlier. Such people are tragically trapped in the past, like a still photograph remaining unchanged while the moving picture goes on.
ولا ثانوي.
انت شو بتقول درست هذا
بعد العملية
بعد العملية
ولا ثانوي ولا قبل العملية عندي شهادة جامعية.
شنو درست في روسيا؟
طب جراحة.
ايوه.
وكهرباء.
ايوه.
ميكانيك.
ايوه.
الكترونيات. تاريخ. شرع المستقبل. ان شاء الله السجادات كتب بالخارج.
ايوه. هتعمل شنو؟
السجادات كتب بالخارج لان العلاج مو موجود.
عايز تسوي عليه. انت بتقول ما هو مريض، شلون تقول
مو مريض. بس استرجاع ذاكرة.
عايز تسترجع الذاكرة.
على جهاز تذكير.
يجي يسووا لك جهاز تذكير.
على جهاز تذكير.
وفين هذا يقولون فين هذا الجهاز؟
في دول الخارج. دول صناعية.
ولو رجعت الذاكرة شنو هتسوي انت؟
كمل دراسة وجامعة.
في 4 يسوي سكرين حق 3 يستلم.
So if we don't have chance for the long pass, we can still get it in.
Another specialization of the human brain is the frontal lobe. These lobes are much larger in man than in any other primate. Indeed, they are the most distinctive feature of the human brain when compared to that of other animals. Given their role in integrating sensory and remembered information, planning for the future, and decision-making, they play an important part in making us human.
Even the point guard, if you see something before I do, where the 4, 3, 2, the 5, the defense is in front.
Damage to the frontal lobes often results in the inability to adapt to changing situations.
Something else that we would run if there's no.
أنت متأكد مرك البيت مرتين اللي دعمك؟
هنيا؟
إيه. مرك هني ولا البيت؟
لا بالبيت.
بس شو أنت ما رحت البيت؟ أنت من يوم ما
عزمني وعييت.
أدري بس من الحادث للحين أنت بالمستشفى. شلون ياك البيت؟
لا جاني أول سنة وثاني سنة وثالث سنة.
وكم سنة الحادث صار له؟
لا الحين 19 سنة. وين الحادث؟ جاهلك الحين. ولا في شعرها.
It's been 19 years since the accident. الدكتور يقول الكلام هذا اللي تقوله مو صحيح. أنت صار لك حادث قبل شهرين والجبس اللي حاطينه على ريلك من قبل شهرين بس مو 19 سنة.
ما لي حادث شهرين.
He says I never had an accident.
لا اللي يقول لك حادث شهرين أو سنة أو سنتين أو 3 سنين أو حادث علي أنا أجف قدامه بالكلام الصحيح أقول كذب. هنية.
يا ليش جاي من المستشفى ومن يابك؟
طال عمرك جيت بطلع من الجارة وقالوا أنت عليك تعميم من قبل بسينا. أي تعميم؟ قالوا والله عليك تعميم. كنت ودوني له.
من اللي جابك وليش جابوك بنظرك؟
أنا اللي جيت طال عمرك.
بروحك جيت؟
إيه أنا جيت بس على سبة الحادث اللي قالوا عليه حادث. ويوم جيت وقالوا أنت ذابح لك رجال.
Who put the plaster in your leg and when?
سألك الطبيب من اللي مجبس ريلك ومتى؟
طال عمرك أعطاني وصفة الطبيب رئيس الأطباء في المدينة. يوم شاف الإشاعة وشاف رجلي وشاف الحادث قال أنا أعطيك وصفة الحين وأعطيك علاج أنت تسويه بيدك ولا عليك جميع شرط.
It was prescribed by him by a doctor, prescribed for home use, as he mentions.
Yeah.
Casting his leg at home.
In a normal case, after the brain injury, the patient is going to answer regarding the past with I don't know, if it is a memory damage. A to B, it's in the next stage A to C, B to C, C to D, but it's not A, B, C, D. The infrastructure to elaborate an idea, it's damaged.
Damage to the frontal lobes can also lead to changes in an individual's personality. Because some mentally ill patients are violent or disruptive, some doctors used to believe that damaging the frontal lobe was a useful way of changing their antisocial personalities. Lobotomy and leucotomy were performed on thousands of patients with behavioral or social problems. In fact, the inventor of the prefrontal leucotomy, who won the 1949 Nobel Prize, is the only person ever to win a Nobel Prize in medicine for a treatment of a mental illness. Needless to say, this treatment is no longer used. Chemical processes in our brains determine almost all of what we are and do. Not only in diseases, but love and hate, sleeping, dreaming, addiction, violence and madness. We've even discovered that such basic parts of our nature as the difference between men and women have simple, identifiable chemical sources. In fact, one carbon atom is the difference between estrogen, the female hormone, and testosterone, the male hormone. Nerve cells are more complex than most cells and project out long fibers called axons. Signals pass down one neuron's axon and pass from neuron to neuron at the synapses. When the signal reaches the end of an axon, it crosses the synapse in chemical messengers called neurotransmitters. These neurotransmitters leap the gap to the next nerve cell, where chemical receptors are waiting to receive them and start electrical activity in the next neuron. It is important that the different neurotransmitters stay in balance with one another. For example, the normal chemistry involved in being frightened by a dog can become unbalanced and lead to an irrational phobia for all dogs. Indeed, if the chemical neurotransmitters are interfered with by drugs or disease, the functions of the brain can be disturbed. If the neurotransmitter that is involved in many visual functions, serotonin, is interfered with by LSD, which causes visual hallucinations, visual images can form and change independently of what images are in the eyes, as the visual cortex struggles to interpret wild and unusual activity produced by altered serotonin signals. Disturbance of the chemistry of serotonin may cause chronic headaches and depression, as well as its visual effects. Indeed, decreased serotonin is a feature of the brains of suicide victims. Another neurotransmitter, dopamine, is also involved in many different brain systems. It's thought to be involved, for example, in the control of movement and the excitability of the cortex. Disturbances of dopamine chemistry result in conditions as diverse as Parkinson's disease, Tourette's syndrome, manic depressive psychosis, and schizophrenia. Science has found ways to treat or control some of these problems by trying to counteract chemical imbalances. But because the neurotransmitters which have gone wrong are distributed in many different systems, treating one disorder can result in others appearing. The treatment of schizophrenia with major tranquilizers, for example, often quietens the hallucinations that happen in this disease, but gives rise to disorders of movement. Scientists hope soon to be able to target these treatments more precisely to the malfunctioning parts.
نعم. أنا كنت لسه بسأل الريان بقول له اللي ما يعرف السرقة.
Another way to affect the chemical processes in the brain is to alter a person's environment or behavior. Hence, psychotherapy, talking over problems with a patient, may have a similar effect to giving drugs to correct chemical imbalances. Biofeedback and listening to calming music are other examples of trying to change the chemical processes in the brain from the outside. So things in the environment, like soothing music, can have a similar effect on the brain to taking a drug, like Valium. The outside world and the inside world of the brain chemistry are hence closely linked. The fact that disorders of brain chemistry can result in violent or strongly antisocial behavior raises many questions. Does it, for example, account for all antisocial behavior? If so, will science one day be able to eliminate all violence from our society? Can good and evil be explained away merely by metabolic changes in the brain? The goal of religious and all ethical systems is for a better and less violent mankind and a liberated world. Science is the result of the 1% genetic advantage we have over our closest relatives. Yet our checkered past has made us fearful, not only for our present, but also for our future. The future of mankind is in our hands. Let it be a future worth waiting for.